Hi, today we're talking about circles as conic sections, and what you need to know before we get started is that all the parts of the equation that cause transformations of the graph they apply to all of our conic sections. So we start off the very first paragraph of your notes talking about recalling the transformations on parabolas. What caused the vertex to shift left or right? That would have been something that was in parentheses with the x that was being squared. What would cause a vertical shift of the vertex? Something that was not in with x but was outside of it, or perhaps it was in with the y being squared. The same thing is going to apply to circles, ellipses, and hyperbolas. So today we're just focusing in on circles. So to come up with the equation of the circle, if we start with our center of the circle being at the origin as it is in this picture right here, and by the way, you should label this as the x-axis and this as the y-axis. If we have a point on here, xy, then we've got some values going on in this right triangle that is formed when we go along the x-axis and up to the point. And this obviously is our radius. So the radius, of course, is the distance from the center. This x value right here is the horizontal leg length of a right triangle formed within this circle right here. And the y value right here would be the vertical leg length. Okay? So from Pythagorean theorem, we know that x squared plus y squared equals r squared, correct? The sum of the squares of the two legs in a right triangle are always equal to the square of the hypotenuse. And in this case, that's the radius. Okay, so then the definition of a circle, it's the set of all points that satisfy this equation. This is true when we have the origin at, or the center of the circle is at the origin. So we will show some examples when the center is moved away from the origin in just a minute here. So in example 1, we just want to find out if this point is really on a circle that has that equation. How would you tell? You would use this equation as a point tester. Plug in 3 for x and plug in 4 for y. So is 9 plus 16 25? It is. So you would say yes, that point is on the circle. How about this point? If the point 3, 4 was, isn't the point 4, 3 also going to be on there? Okay, we got commutative property going on in there. So yes, that point would be on there. How about this one? What happens when you square a square root? It undoes it, right? So is 2 plus 3 equal to 25? No. So that point is not on the circle. How about this one right here? If we square the square root of 21, we get 21. And if we square 2, we get 4. And so that obviously equals up to 25. And yes, that point is on the circle. Now, let's work our way backwards and figure out what the radius is. You need to remember this is the radius that is squared. So you need to take the square root. So in your side margin on the Cornell side of your notes over there, that side margin that's blank for you, you can write a note right there. We know that 16 is some number squared. And yes, when you take a square root of a number, you know, if you were solving an equation, you'd be taking plus or minus the square root, but we're not doing that here. We just want the square root of positive 16. We're taking the positive root only, so we're going to have a radius of 4, okay? We're not going to take plus or minus the square root right here. We cannot have a negative length here, so in this case, we'll only take the positive root. So this is something that you could put over here in your side margin. Only take the positive root. We're dealing with a length. Can't be negative, okay? So in part B, we have this equation. So 5 is some number squared, so the radius must be this positive square root of 5. And go ahead and leave your answer in reduced radical form, okay? I'll show you what we do when we're actually going to graph these, how you can estimate that without using a calculator. Okay, does this equation look like it's in the correct form? Don't we need the x squared and the y squared on one side of the equation and the radius on the other side? So we're going to move the negative y squared. We're going to add y squared to both sides, and we're going to add 4 to both sides. So this is the proper form of our equation for the circle, and then therefore your radius must be 2. Okay, and now in example 3, we want to write the equation of a circle that's centered at the origin whose radius is given. So this is easy. We're just going to plug it because it's centered at the origin. We just have x squared plus y squared, and now all we have to do is square the radius. So when you're given the radius, you need to remember to square it when you write the equation of that circle. So you have x squared plus y squared equals 81. I know I'm going a little bit fast, so you can pause this video anytime you need to. What happens when you square the square root of 7? You just get 7. So there's that equation. And in this one, what happens when we square that quantity? 2 square root of 5 times another 2 square root of 5. 4 times 5 is 20. 2 root 5 times 2 root 5 is 4 times 5, which is 20. So there's your equation for that one. So now we're on the back side of our notes. Now we're going to actually move the center away from the origin. So you have this equation here. It's looking a little bit familiar. Now you have h. Again, anytime there's a number inside the parentheses with x, it's associated with, it's h. It's associated with the x coordinate, okay? Anytime you have something in the parentheses with y, it's k, and it's associated with the y coordinate. And in this case, these are h and k are the center of the circle, and the radius is r, so you'd have to take the square root of that if you were given the equation. So just remember, the other day when we had parabolas, hk was the vertex. Well, hk is just the center of the circle. So knowing that, you ask yourself, what number would make this 0 in the parentheses? Whatever your answer is, if it's positive, it would shift right. If it's negative, it would shift left. What number would make this 0? Again, why 0, 0? We start out, the parent graph, we start out at the origin. So I always ask you, what makes it 0? And again, that's because there's a negative in this formula. And so when you see a plus there, it's because h was really negative or k was really negative. So it was just an easier way to remind you where it's going. So in this example, you're going to tell me what the center is, what the radius is, and then you're going to graph the circle. You don't need to use a compass unless you just can't stand it if your circles don't look perfectly round. I'm not expecting perfection, but I am expecting it to not look like a parallelogram or something. They shouldn't look like segments in your picture. They should appear to be as circular as you can make them, okay? So in this case, you notice we have nothing in parentheses. It's just, that would be like the parentheses of x minus 0 being squared. And that would be like the parentheses y minus 0 squared. So again, this one is centered at the origin. And you should now have figured out that this radius would be 5. So plot your center, go left, right, 5, and up, down, 5. Go out in all 4 of those directions, 5 units, and draw your circle. Okay. In example 2, you notice we don't have anything with y, so that coordinate will be 0, but what makes this 0 over here? What value would make that 0, that quantity? Negative 2. So negative 2, 0 is your center, and the radius will be positive 3, obviously. So go to negative 2, 0, and plot your center point. Go up, down, left, and right 3 units, and graph your circle. Okay, example 3, now we've got something in parentheses with the x and with the y. So again, what would make this 0? Positive 3, so positive 3 is the x coordinate of the center. What would make this 0? Positive 1, so positive 1 is the y coordinate of the center. Now here's something over here. To figure out this radius, we need to take the square root of 40, correct? So you have a little space on your paper here. When you give me the answer for the radius, I want it in reduced radical form. So on the side, you would be figuring out how to reduce the square root of 40. So there's numerous ways you could do this, but you're looking for perfect square factors of 40. And probably most of you have figured out 40 could be written as 4 times 10. 4 being the perfect square factor. So if the square root of 40, let's see if I even have it up here. If the square root of 40 is the square root of 4 times the square root of 10, that reduces to 2 times the square root of 10. So again, I want your answer to be in reduced radical form, but then we're going to estimate what this number is when we're graphing it. So what two perfect square numbers is 40 in between? Right before it would have been 36, right? And right after it would be 49. So those are the two perfect squares that 40 is in between. And the square root of 36 is 6. The square root of 49 is 7. So therefore, this value has to be between 6 and 7 units away from its center. Again, we're leaving the answer for truly what our radius is in reduced radical form. I don't want a decimal answer there. But we're going to estimate it by finding the two perfect squares that this number is in between and using that as an estimate. So we know that it's not exactly 6.5, but we're going to go somewhere between 6 and 7 units away. So we're estimating between 6 and 7 units away from here. So somewhere over here. Actually over here, sorry. We're going to go more than 6. So going 6 units would give us to here. We got to go between these two values. So do the same thing over here. 1, 2, 3, 4, 5, 6. Somewhere right in there. Do the same thing. Go up a little bit between, on the graph you can go about 6.5 there. So in all directions, left, right, up, down. A little more than 6, but don't go exactly 7. Okay, and then draw your circle. All right, so that's how you do it for those types of questions when the radius is not a perfect square number. Now, look at this example 4 that's on your page. Look at that equation. Did we ever see fractions outside of our parentheses? I guess we could have fractions in here. There's nothing that prevents us from having a center that may not be at integer values for its coordinates. I didn't give you any like that, but we could have something like that. However, we didn't have anything out here. We didn't have fractions below these quantities. When you see those, that's going to be an ellipse, okay? So right now, what we need to do to get it into the standard form of a conic section for a circle is it can only be some kind of quantity of x squared plus some kind of quantity of y squared equals some number that's r squared. So we need to multiply both sides by 4. So if we do this and multiply both sides by 4, these will cancel out over here, and then over here we would have 64. So again, these are the numbers that are being multiplied over here. It's like 4 over 4, or 1. You do not ever take that and divide it by 4. Remember again what I said the other day? We've got order of operations in here. And no, we're not going to FOIL these out. We don't want to square them. We want to leave them in this form. So this right here is the correct equation for this circle. So now, can you identify its center and its radius? And you should have written 2, -3, radius of 8. So plot that on your circle. There it is again. There's your center. Make sure you're getting your center point graphed correctly, or else everything else is off. Up, down, left, right, 8. And sometimes these might go off your graphs. That just might happen, okay? Unless we have a larger graph or you use your own graph paper. Okay, that's part 1 of the video.